David is an exercise science and strength and conditioning professor at Florida International University and has been in the consulting game for about 15 years. Ed has received his master's degree in exercise physiology and has also been involved as a strength and conditioning consultant for those 15 years. He's currently a partner at Strength Pro and is the director of the High Performance Specialists. They'll be speaking on optimal power training programs today. Let's welcome David Sandler and Ed McNeely.
Thank you. All right, looks like we scared away some of the people that were here from the earlier talk, and I recognize some of you from our power certification. Those of you who were sitting here on Friday for the power certification, the first couple slides are definitely going to look the same because we want to talk a little bit about our power continuum. Then it'll change up a bunch, so it'll be worth hanging around for. So if it seems like you're seeing the same thing over again, don't worry, it will get a little different. So the thing we want to do here is talk to you about our philosophy about training athletes and training individuals that are a little bit higher performing. So we have to take the assumption that we do have some progressionary training already under our belt. So we're assuming that you have some base level with these people before you would start some of these more advanced training programs. So if it seems like this a lot and you're saying to yourself, I have some people that I'm working with now and there's no way they could do this, that's because a base definitely needs to be developed. So real quick, a definition of power. There's many definitions of power. Our philosophy on power is that we need to try to create an environment in which you can become most explosive as it will be advantageous to your sports performance. And so there are physics definitions of power, and then there are physiological definitions of power, and then there are what we call our definition of power that relates to sports. And so that's how these things kind of work. The physics definition of power is simply the rate at which work is performed. And that's great if you're an engineer, an easy thing to measure. Unfortunately, in the human body, we need to do this with the physiological requirements, and that is to be able to get energy to the muscles to do the movement. So we need a physiological definition, and then we need an extension from that. So our physiological definition is the rate of transformation of the metabolic potential energy. Okay? And we take that one step further to say we need to be able to do this by combining strength and speed optimally. And that's what power really is. It's the optimal combination of strength and speed. And if we use that as our working definition, then this study and this stuff that we're showing you here will make a lot more sense. These are just some physics definitions. Again, I threw this out on Friday just to give you guys an idea. Those of you who like that physics type of stuff, you can see how the formula for power has been derived. The key one for us right here is force and velocity, also commonly called strength and speed. In true physics, for those of you who have a physics background, there's not an exact, they're not exactly the same. Force and strength are not exactly the same term. But for our purposes, we're going to interchange them. So we're going to talk about developing maximal speed and maximal strength. And that's not an easy thing to do because we don't have a lot of time in a work week. And all of your athletes are going to come to you with different levels. Some are going to possess high speed, some are going to possess high strength, and ultimately they all need to possess the amount of power necessary to excel at their sport. So we introduced this concept, and this is something new that we've developed recently over the last few years, and we've been working with our athletes on this thing called a power continuum. And what the power continuum says is that sports fall along a power continuum. To some degree, there are high-end speed sports, and to other degrees, there are high-end strength sports. And our working definition for speed is slightly different, as I will explain in a few minutes. Well, somewhere in between the speed and strength, as we've just spoke about, is where power lies on this continuum. And depending on how you fit on this continuum, you may be slightly to the left or right of power. And so we've come up with some categories that fit in between, and we have working definitions for those categories. So what we have here is a speed-strength category, which is more towards the speed end of the spectrum, and then we have a strength-speed category, which is more towards the strength end of the spectrum. We're going to show you how to classify these so that you can use this in the development of your exercise programs. So, here's the quick definition for speed. Now, again, when we do this, and as I told the group on Friday, we don't expect you to buy into this 100%. But this is some working definitions that help really decide what it is you're training. And no doubt, just after spending this weekend here, listening to all the other lectures that are going on, you're probably saying to yourself, oh, how am I going to do all this stuff? That was great, I need to do this. That was great, I need to do that. This is great, I need to do that. And that's the problem. All this stuff is great. Everything seems to work. If it didn't work, then you wouldn't have guys like me standing up here and and the other people, the other presenters standing up there talking to you about their methods. So the trick for you guys is to figure out what it is you need. And that is a trick. That comes from years of experience of training. So what we tried to do is figure out a way to help you guys decide, what do you need more? Do you need to spend more time in the weight room? Do you need to spend more time doing balance development? Do you need to spend more time doing quickness, coordination, acceleration, agilities, and so forth? Well, to help you determine that, we've come up with a criterion for selecting where you stand and where your sports stand and where your athletes stand. So our speed end of the continuum then, unlike most people, just assume speed is running. But in actual fact, since you are pushing your body along the way, that's not the most high-speed kind of movements that occur. The most high-speed movements that occur are movements that happen in something like a throwing or kicking type of movement. Swinging a tennis racket at 150-mile-an-hour serve, now that's high speed. Okay, kicking a ball, throwing a baseball at 90 miles an hour plus, that's speed. Running, even though your legs turn over relatively quickly, it's not as quick as you would find when you're throwing or when you're kicking. In the 100-meter dash, you take about 45 steps. Well, not me, but an elite world-class sprinter takes about 45 steps down the 100 meters. And that seems really fast, but in comparison to doing like a 90-mile-an-hour pitch, as I said on Friday, the shoulder rotates at over 7,000 degrees per second. 7,000 degrees per second. Now that's high speed. Are we doing the right thing with our athletes, trying to help them develop speed by spending a huge amount of time training strength? And our thought is maybe not. Maybe we need to think about this a little more carefully. So we've come up with this working definition of using an unloaded or lightly loaded limb. Swinging rackets, golf clubs, kicking, punching, throwing a ball. This is what we are calling speed. And again, like I said, you don't have to buy into this thing 100%, but if you use these operational definitions, this stuff's going to really start to make a little sense. Speed strength then. Now this is where we put our sprinting in, speed skating, and in rapid changes of direction. Rapid changes of direction. How many sports require rapid changes of direction? Well, just about every one of them, right? Tennis, soccer, football, rugby, hockey, all these sports require rapid change of direction. So many of these sports are going to fall under this speed strength area, as you're going to see. So it's basically the ability to accelerate the body and achieve a high velocity. And notice it says here, in a horizontal fashion, and we don't have any opponents in our way. Okay? Because once we have to push through someone, we have an added level of resistance. Okay, so we're talking about unloaded, just our body weight, and we're talking about moving horizontally. And that's going to be slightly different than power, as you're going to see. In the case of pure explosive power, really the activities that are really explosive in that nature is what we call jumping. Any of the jumping type of movements. Because the power you need to develop has to go straight up vertically, and so you have a 100% fight against gravity versus doing something horizontally. And for those of you who have a little bit of physics background, your vector mechanics will tell you that horizontally, your down force is converted in a horizontal fashion. Well, in the case of jumping, your down force is converted directly back up vertically. And then you have the full 9.81 meters per second of gravity to fight against. So you have to develop enough force at enough rate to do this. And this we call explosive power. And so then you ask yourself, geez, how many sports have explosive power? Quite a few of them. Anytime you see jumping, volleyball, basketball, and any sports where you're going to require some jumping, maybe the goaltender in soccer versus the players that are doing more of the horizontal running, and in some cases some of the players even more aerobic conditioning. So this can really start to get confusing because no doubt if you're a strength coach and you've been working with a group of athletes, because you don't have enough time to train every one of them individually, you tend to lump them all together and have them all do the same thing. As we're going to see, that's going to present a bit of a problem. The strength speed end then says we're going to move heavy implements or opponents, but we're going to still be able to do it relatively rapidly. It's not going to be quite as quick as what would happen if I just moved my body, but it would be more quick than doing a heavy and weightlifting type of movement, as we'll come to in a moment. And so it's pretty easy to classify these, things like throws and judo and wrestling, football line play, pushing against one another, okay, the shot put, the hammer throw, any of these heavy object throwing type of movements. And then things like skating, checking, and even in soccer where you're running down, chasing after a ball and you're jostling with one another. Wide receiver has to make a few moves on a deep back and gets shoved around a little bit. So those are all what we would call our strength speed category. And then last but not least, this is kind of easy to look at. This makes a little bit of sense. It's just weightlifting, basically powerlifting, and all those things we do in the weight room. And no doubt, most of you do personal training, spend most of your time in the weight room with your clients, because this is what personal training is. We take you through a set of machines or a set of free weights, and we talk to you a little bit while you're doing them, and we try to arrange them strategically to get you so you're working pretty hard. And ultimately, that's helping you with your planar movements in those specific planes. But the last time I looked, I don't remember a single movement in all of sport, and for that matter in all of life, that operates in one plane at one time. Simple tasks like even drinking is not just arm flexion. There's abduction, there's internal rotation, there's all kinds of other movements going on. And so I take that a step further and look at things like throwing a ball, hitting a tennis ball, kicking, and I see all the rotational components of the body, and I see all these different planar movements. And strength training then has very little carryover. The strongest person does not always win. And so we have to kind of keep that in mind, because as we're going to look at this in a little more detail, we're going to realize that maybe the weight training stuff that we've been doing needs to be toned back a little bit, and we need to try to add some of these other components into our training program. And as a former powerlifter, I love strength training. I think it's great to be able to get under a huge amount of weight and squat and bench and do all that kind of stuff. But I rarely ever have any of my athletes doing that, because it's not beneficial to them. So here's the problem, though. Of course, very few sports are going to fall into one category. Like I said, we have the extreme end of something, but in most cases, very few sports are going to fall into one single category. So we need to do what we call a sports analysis, and that is to figure out how we categorize the different people that we're working with. And really, the sports analysis, every one of you already do this in everyday life, whether or not you realize it. Every one of you are researchers. And you probably don't think of yourself as a researcher, because your definition of research is probably that of one in an institution like I'm in, where I teach, and I'm required to publish papers. But most of you guys all do research anyways. You go to the grocery store, pick up a can of some food, take a look at it, read the label, look at another can, compare the two products. You're doing research. You're doing research. You're analyzing two different things and making a choice of which one is better for your particular needs. Those needs might be taste, they might be for whatever it happens to be. Well, that's the same thing you should be doing when you're training your athletes. Instead of just listening to all of us up here talk about our great methods and how wonderful our training methods are, maybe we should be saying, maybe I should look at this a little more carefully and see what my athletes really need. Because your athletes are different than mine. We've worked with young kids all the way up to professional, NFL and Major League Baseball, hockey, and so forth. And they all train slightly differently. So do each of the players in those different sports. And so maybe we need to get this thing looked at a little more detail. And that's what we're just trying to give you guys here. We're trying to give you a little groundwork, something that's going to help you work with. There's a lot of research that exists out there, but don't forget, you guys are good at what you do. You're coming here to get some ideas, but you guys are good at what you do. Nobody knows the people you're working with better than you. So give yourself a little pat on the back because you're probably doing a pretty good job. Now you're just looking for ways to make it a little better. We like to do time motion analysis. We have high-speed video cameras that film at 8 times the speed of normal video cameras, so we can slow it down to 8 times slower. We film at about 250 hertz for those of you who like the scientific numbers. Really high-speed cameras that can really give us some great information. You guys will get that information even from a general video camera. You don't need one of the high-tech cameras that we use to see much of what's going on, especially when you want to look at things like, hey, how many times an athlete jumps, how many times an athlete twists, how much strength is being applied, and so forth. Okay? And here's another thing. If you're missing a large chunk of the action because your camera films too slow, that's what's considered high speed. Because even in our cameras that can film at 250 frames per second, that's 250 frames per second, we miss a huge chunk of information on a baseball pitcher throwing at 90 miles an hour. They exceed the cameras we can afford at our university. And you have to get into 500 to 1,000 hertz cameras, which are into the hundreds of thousands of dollars per camera to analyze movement. That's how fast that is. Well, that's enough to tell me, you know what? That's high speed. If you guys can't see it even on your regular video camera, it's probably moving at a very, very high velocity, and that would automatically put that movement into the high-speed portion of the continuum. So you don't need the fancy stuff that we have. The fancy stuff that we have just kind of confirms what you guys are already seeing. Here's ways to look at sport. Look at how much time is being played, what the work and rest intervals are, the duration of the work and rest periods, and the types of movements and skills that are being performed. If you start to analyze that and mark these things down, you can determine roughly how much time your athlete is spending in a particular portion of the continuum. You don't need to do this, although we do, because again, we like doing that type of stuff, and as a university professor, we're required to do this kind of junk. But this junk you guys already know. You pretty much know how much force. You may not be able to classify it in terms of how many newtons of force are being produced, but you got a pretty good idea of the kind of force, the kind of strength, the kind of speed required to do the sport. You also have a pretty good idea of the EMG, the muscle activation. We just kind of confirm it with EMG. We look at the muscles while they're moving and get a little bit better idea of what's going on. But again, if you have a little bit of an anatomy background, you can pretty much determine which muscles are involved in those kind of movements by muscle actions alone. This is what you need to look at, is how fast these things accelerate and move. And again, you do not have to quantify this with a number set. Okay, you can visually see this relatively easy. It's nice to look at elite athletes. That's fabulous. But the problem is many of you aren't working with elite athletes. So now I tell you about the stuff I've done with a bunch of the NFL guys that I worked with when I was at the University of Miami. And that doesn't apply to you guys because you're not working with those athletes. And so when you use elite information, it's great to give you a basis, but remember, you have got to categorize this within your sports that you're working with, within your athletes. So if you're analyzing game film and you're looking at NFL football players and what they do, and now you're going to take your 10 or 12-year-olds that are playing football and try to develop a training program, there's a big difference in what's going on. You ought to be watching the 10 and 12-year-olds play and figure out the best training methodology, not bringing in our NFL strength coaches to tell you how to do it because they're used to working with much higher level athletes. And of course, let's not forget injury. There's a lot of that talk this weekend, which is great. We like to do what we call prehab, as we talked about on our Friday in our Friday workshop. We try to develop some areas before they get injured. So we do strengthening of the shoulder and the ankle capsules and the knee and so forth in some isolated strengthening movements. But even then, when we do those movements, even then we do them at a higher speed. And we do them at the speeds in our strengthening and our rehab or prehab, if you will, at speeds that are similar to that of which is seen in the sport. Like doing internal and external rotation for the shoulder for a baseball pitcher who's now going to rotate his arm at 7,000 degrees per second, and I've got a 5-pound dumbbell and I'm going through this motion, that ain't going to help him. That's fine if you're injured and you're repairing something. But if we're talking about doing this at this high-end explosive speed that they're going to need, then we need to be training them that way. So we should be looking at ballistic, explosive, maybe tube-loaded type of resistance movements in those planes that they're going to move in. Again, a little bit different philosophy probably in some of the other things you might have heard this weekend. But I'm looking at the function that I want my athlete to do, not where my athlete is right now. Where do I got to get him to? Again, obviously we need progression. So when we talk about these things and do these things, we're assuming that there's been a proper progression along the way. And we'll show you that in a little bit. This is really hard for you guys to see. Those of you that took our course on Friday, you got this in a better copy. You'll all see this on your CDs when you get home and pop them in your computers and so forth. What this is a chart showing how much percentage or the relative percentage of time each of these particular sports fall into the continuum. And so, for example, if I came up to baseball, about 45% of the time, baseball players are in the speed zone. That's rotating around on a baseball with a bat or rotating around the shoulder when you're throwing the ball. About 30% of the time, they're in speed strength. And then the rest of the time is a little bit in explosive power, although most people tell you it's explosive. Well, it is explosive, but it's an unloaded explosive or a bat-loaded explosive. Okay, so it's a slightly different categorization tool that we use for them. Now, having said that, if you look at this thing, you're saying 0 strength, so that means I need no strength for a baseball player? That it's not what it means. Okay, when you see 0 in a category, it doesn't mean don't ever strength train with a baseball player. It just simply means that when we analyze sport, the bulk of the time the athlete is spent in this portion of the continuum. That's what we need to finalize. That's what we need to get to. That's what we're trying to improve on these athletes. Okay? That's what we are trying to improve. I need high ballistic rotational speed. Not slow rotation. Not taking my time doing some kind of slow rotation. I am swinging around a baseball bat at a ball coming across the plate at 95 miles an hour. Okay, that is very, very high-speed, rotational, violently ballistic movement. So that's how you classify when you work with this table. You'll see we've got football in a 0 down on the speed end, because in football you are never, and other than a kicker, the quarterback part of the time when they're throwing the ball, but everybody else is running under a loaded condition, their body weight plus a uniform. So we spend time doing speed strength. And this is the key to success when you look at some of these higher college football teams. People used to ask me, how much time do you spend in the weight room with the University of Miami football players? And the answer was, well, about 45 minutes. Why? Because we felt that explosive speed was more important on the football field than being able to bench 400 pounds. Okay? That's how this stuff works. This table was developed with a whole pile of strength coaches and some research that we have done ourselves and some other researchers have done. You don't have to buy this thing 100%. Certainly we are open to suggestions as well as terms of how this thing really should be broken down. But this gives you a general guideline. If you look at it, it makes sense. Analyze the sport for what it is and determine where it fits on the category. Then look at developing your program. Yeah? What's that? I influenced Jimmy Johnson? The question was, did I influence Jimmy Johnson? Actually, Jimmy Johnson was there before I was. I worked with Butch Davis in that group. So the answer would be no. So anyway, this is a thing for you to look at. Ed's going to jump up here now and continue on talking about how we integrate this stuff. And then I'm going to come back at the end and tell you how we put it together in a program. All right?
Yeah, I just quickly want to go through some of the adaptations to strength and power training. Essentially what we're looking at is any high speed, high strength, high power activity that you're doing requires not just the muscular system but the nervous system as well. And a big part of your training is really focused on this battle between nervous system adaptations and muscular system adaptations that most of you have experienced with a beginner. When they come into a program, the first few weeks you see very rapid increases in strength. Those are all nervous system adaptations. It's the process of learning how to activate the muscles you've already got. Only after that do you actually get into hypertrophy. And hypertrophy is essentially, it's just an increase in muscle size. We look at two main types of hypertrophy, what's called myofibrillar hypertrophy. Now, the myofibrils are the individual protein filaments that make up a muscle. And we also have sarcoplasmic hypertrophy, which is an increase in whole muscle size. This improves performance. This doesn't improve performance unless you're a bodybuilder. Okay? So increasing the size of the myofibrils, think of it as increasing the size of a cable. If you have a steel cable and you increase the size of that cable, you're going to have a stronger cable. If you just increase the amount of insulation you put around that cable, which is what we're doing here, you're not necessarily going to have a stronger cable. So we will tend to stay away from traditional bodybuilding type movements and bodybuilding type programs when we are dealing with athletes. Because ultimately, sarcoplasmic hypertrophy will decrease endurance, it will decrease skilled performance, and it will decrease speed. Whereas the other end of the spectrum, our myofibrillar hypertrophy, increases the cross-sectional area of the fiber, and therefore strength, speed, and power. Okay? This is just sort of what it looks like. In sarcoplasmic hypertrophy, if this is the muscle when it starts, you're getting an increase in the whole muscle size, so the measurement is going up, but you aren't seeing much of an increase in the size of the fibers themselves. With myofibrillar hypertrophy, we're seeing an increase in the size of the fibers themselves, but a smaller increase in whole muscle size. This becomes a really big issue, and a lot of you have probably heard it working with young athletes, whether it's football, hockey, whatever it happens to be. They come to you and they say, my coach told me I had to gain 20 pounds over the summer if I want to play next year. Well, you know what? It is possible to put 20 pounds on them over the course of the summer, but you're going to be doing this. And that when they gain that 20 pounds, unless they're going through a natural growth spurt at the same time, what you are going to find is probably decreases in a lot of the on-ice performance or on-field performance parameters. So if you want your athletes to be bodybuilders, train them like bodybuilders. Otherwise, the focus should be out here as opposed to just trying to increase muscle size. Let's look at the nervous system a little bit. First of all, we want to talk about motor units. Motor unit, this is the functional unit of the neuromuscular system. Every movement you do is a pattern of motor units. So this is the nerve and all the muscle fibers that are connected to that nerve. Smaller motor units are going to give you fine motor control, larger motor units, gross motor patterns. Normally you will activate motor units from the smallest motor units to the largest motor units. So activating from what are called slow twitch fibers to the largest fast twitch fibers. Okay, nice little picture of a motor unit. And this is just basically showing that activation scheme. If you were looking at resistance training, when you are down at 10% of 1 RM, you're starting to activate slow twitch fibers. You don't actually activate the biggest fast twitch fibers until you get out here above 80-85% of 1 RM in strength training. So if you're dealing with, if you're looking just on the pure strength end of the continuum and you're only training down here at 60% of 1 RM, you're really not activating the fibers and using the fibers that are going to give you the largest strength increases. This is what I was talking about earlier. You see that early on in a training program you have neural adaptations, and they start off being the biggest contributor to strength and power increase or strength increases. And then as time goes on, hypertrophy plays a bigger and bigger role. Now, what do you think's happening to the nervous system when hypertrophy starts to take over? Any ideas?
Decreases?
It actually starts to detrain. So you get a detraining effect going on in the nervous system. So essentially, part of what's going on in training is there's this constant battle between creating nervous system adaptations and creating muscular system adaptations. And part of the way you structure your program is to take advantage of this. So many of the traditional linear periodization models start off with hypertrophy early in the year, and then you just basically progress the intensity up and the volume comes down in a linear fashion throughout the year. But what we're seeing more and more now is that those linear models in a lot of the strength and power sports are not as effective, particularly if you have a long competitive season that you see in many of the team sports. A better option actually becomes doing a period of training where you're focusing on neural adaptations, so higher speed, higher power, higher resistance type work, and alternating that with a period where you're doing hypertrophy-oriented work, so slightly higher volumes, lower resistances of training. And then alternating those back throughout training cycles. So doing a cycle of really high speed, high power stuff, backing off doing a cycle of muscular adaptation stuff. The added advantage of that is high speed, high power oriented training is very difficult on the nervous system. Creates a lot of neural fatigue, and neural fatigue takes a long period of recovery. So by alternating between a short cycle of speed power, short cycle of muscular adaptation, you're actually allowing time for the nervous system to recover from the training stimulus you've given it. Some of the neural adaptations that we see. First one is there's an increase in the number of motor units activated. How many of you have read some kind of a story about, a mother whose child is trapped under a car and she lifts the back end of the car off them? Well, just about everybody is capable of doing that. That's within your capacity to do that. The problem is you need to be able to fully activate everything and fully synchronize everything in order to do that. Part of what you are trying to do with training for speed and power athletes is to get them to be able to voluntarily do, through more activation and increased firing frequency, what people normally only do in emergency situations. So you're looking at these neural adaptations to really take advantage of your full muscle potential. And this is what this shows. Okay? When you start off training, you're at this level here. This is your voluntary strength. Evoked strength, this is referring to if we took electrodes and sort of went right into the nerve root, and when you tried to do say a leg extension, and we just cranked up the electricity on it so it sort of overrides the signal coming down from the brain and then just fires everything maximally all at once, this is the strength that you get here. This is what you start at with training. As a result of training, you bring this closer, your voluntary strength, what you can elicit, closer to the evoked strength, which is representative of the strength of the true strength of the muscle tissue itself. Okay? Neural adaptations are most important for speed, power. Now let's quickly get into some of the training methods themselves. And these are just a couple of fun, interesting little things that people are experimenting around with right now. Some of them are a little more practical and a little easier to implement than others. First one we want to look at is velocity-based strength. One of the things we know with strength increases and power increases is that they are going to be most effective when they are on what is called the force velocity curve. And basically what the force velocity curve is, right here, is this line. And it basically says that at very high resistances, very high forces, you're not going to be able to move very quickly. At very low forces, you can move very quickly. To train on the curve, what speed do you need to train at? If you were looking for optimal power developments, what speed do you need to train at? Do you want to be standing there doing this? Well, we'll take 2 to 4 seconds to lift it up and then 2 to 4 seconds to lower it. It's maximum speed for whatever resistance you were using. So to be on the force velocity curve, here, here, wherever it happens to be, you need to be moving whatever resistance you have as fast as you possibly can on the concentric. That doesn't mean that, say you're doing it on a bench press or something, that you throw it up and then you just let it fall on you. Okay? What it means is that the concentric portion needs to be as fast, as dynamic as possible, as explosive as possible. That's where you will get, even if the weight doesn't move very fast because of how heavy it is, you will get your best training adaptations when you are moving the weight as fast as you possibly can. The other thing we know is that when power and velocity drop below 90% of max for any given resistance, you are no longer getting a power training effect from it. You might still get some kind of an endurance effect. You might be able to produce hypertrophy with that. But if your objective is to increase power, anything below 90% of max is not going to create the adaptations that you're looking for. Now, that doesn't mean it's 90% of max weight. What it means is 90% of max velocity or max power. Now, what we also know is that fatigue occurs very, very quickly due to a depletion of ATP. So this, you can actually look, this is a little study Dave did at the lab down in Florida, and you can see just over the course of 3 reps, significant drops in power output. So in as little as 3 reps, you are seeing drops in speed, drops in power. So this has implications for how long your sets are. You're really not going to be able to get out there and do sets of, 6, 8, 10, 12 reps when you are looking at developing optimal levels of power, really regardless of where you fall on that continuum. So how do we go about doing this type of training? Well, right now there's a couple of companies that are making these neat little machines that will actually measure the velocity that the bar is traveling at. And I'm willing to bet that over the next 4 or 5 years, you will see more and more research and more practical application in strength training being built around measuring bar velocity. So what this will mean is, instead of saying to somebody, I want you to do 3 sets of 5 reps at 80% of your 1 rep max, training programs are going to start looking like, I want you to lift this resistance at 2.5 meters per second. So now you've got that speed component. That's the component that's always been missing in power programs, is missing that speed component and how you control that speed component. So in the very near future, a lot of strength training programs are going to become velocity-based, meaning prescriptions based on speed rather than prescriptions based on repetitions to failure or percentages of 1 RM. So typically, a lot of the people that are working with this right now have specific velocity targets. So they want somebody to doing a squat at about 1 meter per second. You're looking at hang cleans of about 1.5 meters per second. There's, power snatch 2 meters, 1.1 meters per second for bench press, and 1 meters per second for deadlift. Now, sport-specific velocity targets still need to be developed based on the analysis of the sport that Dave was talking about. And this really allows you to target very, very specific elements in a sport. For instance, I've done a lot of work with Rowing Canada. And going into these last Olympics, we were playing with a lot of this stuff. And we had the heavyweight men's 8 training at about 1.2 meters per second for things like squats, because we know that's the speed of the leg drive on the boat. Well, they got to the Olympics, and in their heat, they set a world record. Problem was, they didn't deal psychologically with the fact that the Americans also set a world record and then ended up blowing things when they got to the final. But the training definitely paid off because the boat was faster than it had ever been. And it was based on knowing that training at one speed is going to give you power improvements at that speed. Training very, very slow with a really slow powerlifting kind of squat would not have translated over to the kind of boat speed that they experienced, because we'd used that in previous years. So our goal in velocity-based strength is to increase the weight for a given velocity or increase the velocity with a given weight. You'll terminate sets when the velocity cannot be maintained. Aim for a total of about 15 reps. So that's not 15 reps in a set, that's a total number of working reps of 15. So if you went out and say we were trying to hit 1 meter a second, and you did 2 reps at 1 meter a second, and then your next rep was 0.8, that would be the end of the set. That set would have been 3 reps long. You just keep adding up those total number of reps until you hit about 15 reps at your target velocity. When you're capable of doing 3 sets of 5 reps at target velocity, increase the load at that point. It's starting to get to the point where it's a little bit too light, and you need to look at increasing the intensity. I'm going to quickly go through plyometrics. I'm sure many of you are already, partially familiar with plyometrics. Some of the other presenters have talked about them a little bit in their presentations, and you've probably seen it elsewhere. But essentially, plyometrics take advantage of the stretch reflex and the elastic nature of muscle tissue to enhance speed and enhance power, jump height, things like that. You're training the nervous system to react to contact with the ground. And as such, that contact with the ground needs to be as short as possible. We see 3 phases in a plyometric. So an eccentric, which causes the stretch. As a result of that stretch, we're getting the reflex contraction. There's an amortization phase, which is the period on the ground. This is the crucial part of the whole plyometric. This needs to be as short as possible. Now, we're talking ground, but the same thing may be with hands. If you're throwing a medicine ball or something like that, your contact time with whatever implement or ground needs to be as short as possible. We're talking about 0.3 of a second. Once you start getting beyond 0.3 of a second, you lose the advantage of that stretch reflex. It goes away very, very quickly. The added power you can produce dissipates very, very quickly. That's why it's important to have a good strength base when you are getting into plyometric training. Because your eccentric strength is going to play a big, big role in whether or not plyometric training can be done most effectively. Everybody can go out and do some jumps. And many times, even, an 8, a 10, a 12-year-old, you can put into a jump program. Are they going to get the same plyometric training effect as somebody that is much older and much stronger? No, but they're going to learn jumping techniques, which is then going to pay off later on down the road. So what are we looking at for strength levels? Ideally, to get sort of the optimum adaptations out of plyometrics, we're looking at squatting about 1.2 times body weight for jump training. So that would be just, basic jumps along the floor, multiple long jumps, high jumps, things like that. If we were looking at depth jumping off of a higher box, so that would be something like standing on the stage, dropping off, and a maximal jump out of that, you really need to be seeing strength levels in the 1.6 to 2 times your body weight. Otherwise, you absorb too much force. You absorb too much of the force, you absorb too much of the recoil. Upper body, if you're looking to do upper body plyos most effectively, you're looking at bench press strength levels of somewhere between 1 and 1.5 times body weight. Now, this doesn't mean, as we said before, that if you can't do this, you can't do plyometrics. What it does mean is you can't do the most intense drills, and you aren't going to get the greatest benefit out of doing the plyometrics. So on a scale of, good, better, and best, plyometrics are good for people that don't do this, but they are better for people that do have an adequate strength level. So yeah, you can take your 12-year-old, you can let them do some jumps, but at the same time, you should also be aware that the jumping may be important, but if you are looking at longer-term development for that athlete, maybe you want to spend a larger proportion of your time increasing their strength. So it's about creating priorities in your training. You know, everybody may benefit from plyometrics, but who's going to benefit most? And can I get greater benefit further down the line by focusing on something else? Core strength, obviously important when you're doing this. Always teach landing technique before you start training. And you know, this really sounds funny, but you would be amazed at how few people can actually land properly. You know, they're either sitting back way too far on their heels, their legs are too straight when they're landing, knees are pulling in like this, they're landing all their weight's over on one foot or another. All of that can really set you up for injuries. So focus first of all, your first progression should be teaching landing before you get into any sorts of jumps. Sequencing the exercises. In plyos, you will start with 2-leg or 2-arm activities. Move on to single leg, and then move on to boxes. So you start with jumps or hops in place, single response jumps, which mean a single jump at a time. So you would do one vertical jump, land, reset yourself, do another single jump, land, reset yourself. Then you would move on to multiple response jumps and bounding. Now, how do you know when to move on? Basically, it comes down to watching the individual's technique. When they are getting good at single response jumps, so you're seeing that the turnaround time is very, very quick. Time on the ground has decreased. Body position is good. Then you can look at moving on to multiple response jumps. So look at these things. Look at technique. Look at the turnaround time. Plyometrics, all jumps must use 100% effort or they're ineffective. Same thing really goes with your medicine ball stuff as well. If you're just standing there, tossing a medicine ball back and forth, nice and easy, you are not developing power. The act of doing an exercise is not going to dictate the training effect. It's how that exercise is done that becomes important. Is it a maximum effort? Is it a 100% effort? Are you throwing that ball as hard as you possibly can while still using good technique? If you aren't, then you are not getting a power training effect. You may be developing other things, but you are not getting a power training effect. Plyometrics, volume. Volume is calculated as the number of contacts per training session. So if I do this kind of a jump, how many contacts was that? 1 contact on each foot. So it's calculated as the number of hand or foot contacts per training session. We're looking at beginners coming in doing somewhere between 80 to 100 contacts, intermediate 100 to 120, advanced people 120 to 140. So does this mean these are big, really long, huge workouts? No. If you think about it, if you did 8 sets of 5 vertical jumps, so you just jump up and down 5 times, you did that for 8 sets, you'd be right here. That would be all you would do in that training session. So you're not going to get 8, 9, 10 different exercises. 5, 6 sets of each exercise. These are very short, very intense workouts. You shouldn't be turning these into big, big marathon training sessions. It's just too high a volume. You won't be able to recover from it. Okay. Rest, 5 to 10 seconds between jumps for single response jumps. So if I'm doing just a single response vertical jump, or if I was standing down on the ground and jumping up onto this stage, so you jump up, walk back down, take 5 to 10 seconds, reset yourself, go again. Okay? A rest between reps is not necessarily a bad thing. And they're actually seeing this more and more even in strength training. Years and years ago, there was a training method that used to be called rest pause. And it seems to be starting to make a little bit of a comeback because there's been several studies over the last couple of years that have actually shown greater strength increases if you take a 2 to 3 second rest between your reps. And the reason for that is it allows some repletion of ATP, so the energy system that you're using, so that you can maintain your power output. You won't see that same kind of decrease in power that we looked at in the previous slide if you're taking a short pause between your reps. At least 2 to 3 minutes between your sets for all types of plyos. And this may even get as high as 7 to 10 minutes. If you were doing heavier resistance kind of plyometrics, so if you were doing jumps with a weighted vest, or you were in the speed or strength speed end of the continuum and you were throwing very heavy med balls, doing jumps and throws with very heavy med balls, you may be looking at as many as 7 minutes between your sets in some cases. That's how long it takes for the nervous system to recycle and allow you to do another true maximum effort. Another one we very want to quickly look at very quickly is something called weight releases. And traditional weight training has a problem. You have to slow the bar down at the end of the range of motion. You know, it's pretty difficult. You know, you're going to run yourself into a whole lot of problem. If you're lying on a bench and you're doing a bench press with an Olympic bar, and you take it and you throw it up in the air. Right? That's going to be pretty hard to catch. But that's exactly what you need to do if you want to start developing optimal power through that kind of motion. Because in a traditional movement, we see this happening. That there's an initial force development, and anytime you're getting force developed, it means there's an acceleration. Because force is mass times acceleration. So most weight training exercises, you see an initial period of force, you hit the sticking point, and everybody's got a sticking point. Every exercise has a sticking point. You have another acceleration as you get through the sticking point, and then you have this deceleration at the end where you're stopping. So if you look at the bench press, this would be an acceleration through here, deceleration at the sticking point, another acceleration, and then as you're locking it out at the end, you're decelerating the weight again. That's not the ideal way to be increasing power. The optimal way to increase power is to be able to accelerate. So once you start this acceleration, you just keep accelerating all the way through that range of motion. What you'll even find is that if you can do what's called a weight release, where you actually are throwing the weight away, it changes this whole curve. So even the forces and the power development early in the curve changes. Now, this can be done on a Smith machine. So it's available to most of you in the gyms you're at right now. And it would just be on the Smith machine. It's what I'm saying. You take it, press it, and you will actually have the weight throw, several inches out of your hands. Now, you need to practice this a little bit before you start putting a lot of weight on the bar to do it. And you want to make sure the person that's catching it does keep their hands there. It's not real nice to have this fall on your face. There are also other ways of going about doing it. There are several equipment companies right now. This is a modified Smith machine that a company called Cormax makes. And with this, when you throw it, there's a hydraulic resistance arm in the back here that controls the eccentric, so that you can throw the weight without worrying about the speed that it's coming back down at. It'll come down nice and slowly. You can catch it and explode it off and throw it again. This company here called ProSpot, there's actually a couple of cables that are coming down that are attaching to your free weight bar. When you release, there's a wire on the back of this bar that when your hands come off that wire, the bar will not travel down anymore. It will only continue to go up. So you can throw that, and then the bar just hangs there in the air. So there are ways of doing these releases. Med balls are another way of doing the releases. And depending on where the power continuum you need to train will affect the weight of a med ball you're using. But they have med balls that are ranging anywhere now from, 1 pound. I've seen advertising for some that are as heavy as 100 pounds. So you can actually have a wide range of resistances that allow you to train at different points along the continuum using med balls, doing releases, doing throws like that. Again, short sets, long rest periods, that's pretty much standard for any sort of power-oriented training. Short rest period or long rest periods, very short sets. You need to maintain the speed, you need to maintain the acceleration of the movements. Okay? The 10% drop rule. We've already talked about that briefly earlier when we were talking about velocity-based training, where I said anything that drops below 90% is no longer effective for developing power. You can get that same measurement, you can measure that yourselves just by measuring the distance of a throw. So if we're looking at that Smith machine bench press throw, all you need to do is put a tape measure on sort of the front pins on your Smith machine. So on the front columns. Just note how high the bar goes on the first throw. Then every subsequent throw has to be 90% of that or better. So let's say they throw the bar 1 meter. If the next throw does not hit 90 centimeters, that's the end of the set. So you cut the set off when you see that 10% drop in power output. Another type of training that's gaining popularity right now is called complex training. Some people refer to it as potentiation. And what this is one exercise preceded by another that enhances the second exercise. So there are a couple ways of doing it. There's heavy light, which would be something like doing a very heavy squat. So 95% of 1 RM, 80 to 85% of 1 RM, somewhere in there, doing a couple reps of a very heavy squat, and then immediately follow that with vertical jumps, long jumps, some kind of a plyometric unloaded activity. So what you are attempting to do is use contrasting resistances. Very, very light to enhance very, very heavy. Because what they've seen is that doing a maximum squat or a near maximum squat before doing the jumps enhances the height that you're jumping. 1 or 2 studies also have seen the other way, that if you go light, in other words, doing some explosive depth jumps, so if I was to do 3 jumps where I jumped off here, landed, jumped again, and then attempted to do a maximum set of squats, you would find that you can actually squat more weight. Because what's happening is anytime you are doing a maximum effort activity, it is creating more and more nervous system activation. It's forcing the brain to turn on more and more motor units. That carries over to the second exercise. So now when you start that second exercise, your brain is already kind of juiced up for maximal activation. It makes the second exercise more effective. So playing with contrasting resistances. Again, they're very short sets. We're not looking at doing a set of 12 squats and then trying to do vertical jumps after that. We're looking at short sets of 1, 2, 3 reps, followed by 1, 2, or 3 reps of the second exercise. You don't want to be inducing any kind of energy system fatigue during that first exercise. So if you did a set of 10 or you took a set to failure, are you going to be able to jump afterwards? No, because you've depleted the energy stores for it. So it's a short, intense activity followed by an activity with a contrasting load, meaning you either go heavy, light, or light, heavy. So basically, this is what I was just saying. Involves exciting the central nervous system, more recruitment of muscle fibers, all that kind of stuff to make the second exercise more effective. Okay. These are just some of the data from a couple of studies that have looked at this. So this study looked at 95% of 1 RM, followed up with lighter activities for 2 to 3 reps, and there's good anecdotal support as well as some research stuff. I just want to very quickly go through some basic principles of program design that hold true for all power programming. First one, when we look at repetitions, the number of reps should be chosen to prevent lactic acid accumulation. You don't want to be creating fatigue when you are doing power-oriented training. One of the things people get into with their training is this whole idea of, I want to feel it. I need to feel this working. And one of the ways of feeling it working is you are getting this accumulation of lactic acid. Yeah, I want to feel the muscles get fatigued. I want to feel like I'm working hard. Well, ultimately, when you are looking at power training, you may not necessarily feel like you are working hard during the set itself, because it's going to be very short, very intense. You'll feel it when you stop. You may be breathing harder. You may have a general overall feeling of fatigue, but you won't necessarily have felt, yeah, my bicep feels really tired, or yeah, my quads are feeling really tired and I'm walking with rubbery legs or something like that. Most of that comes from an accumulation of lactate. Most of those feelings that you associate with a good workout come from a lactate accumulation. You don't want that because it robs you of speed and power. So all reps should be done using the anaerobic alactic energy system. So very, very short sets. The duration of your set is probably not going to be much longer than 10 seconds or so. In many cases, you may be looking at sets that are only lasting 3, 4, 5 seconds. So they are very, very short, very, very explosive, very, very intense activities. Rest between sets. The reason we rest between sets, control the factors that cause fatigue. And those are just listed here. Now, your rest duration becomes dependent on your work duration. The longer your work period, the longer your rest period. The things we know for sure. Longer rest periods have always been shown to result in greater gains in strength and power than short rest periods do. How many of you are dealing with clients where you just keep running them, as a personal trainer, running them from one exercise to the next? Like a lot of clients sort of have this idea that, I shouldn't be sitting here. I'm not paying you $60, $70, however many dollars an hour for me to sit here and rest. So they almost expect you to be, going from this exercise and then running over here and doing this and then running across the gym and doing something else. But ultimately, if you've got someone that's training for speed, power-oriented activities, they should be spending the majority of their time sitting on their butt doing next to nothing. That if you look at the total work time in a training session, it ends up being relatively short compared to the total time of that training session. In a 90-minute training session, there might have been a total of 5 or 6 minutes of work. The other 85 minutes really are spent sitting, talking to your friends. Long rest periods allow for the repletion of ATP-CP, allows the nervous system to recover, will help you maintain your speed and power. Get away from this idea of, the bodybuilding idea of doing a set, taking a 30-second rest. If you were able to measure speed, if you start measuring or looking at that 10% drop-off rule, you will find yourselves that these very short rest periods result in drop-offs in speed and power very, very quickly. Okay, this is just a quick table. This is in your CD, so you can look at this yourselves. Just giving you an idea of work times, potential rest times. The reason this becomes so long here is because if you are doing something that's taking you less than 3 seconds, there's a good chance that it's a true max resistance kind of exercise. And we know from powerlifting studies, Olympic weightlifting studies, that it can take as long as 7 minutes to recover between sets of, if you did a maximal clean and jerk, it can take you 7 minutes, sometimes more, to really recover from that. So, generally speaking, though, if you were doing something a little lighter, a little quicker, you could get away with 1 minute rest, 3 to 15 seconds, 2 to 4 minutes, longer period, longer rest. Recovery between training sessions. Recovery time is a function of volume and intensity. So the more volume you try to do, the longer your recovery period needs to be. The other thing you need to consider is all the other stresses that can impact recovery time. So if you are dealing with student athletes and they're coming into an exam period, you should consider dropping training volumes, dropping training intensities, because that external stress is going to affect recovery time as well. This is just a graph that sort of shows what happens with a training session. Start there: fatigue, recovery, adaptation. And there's another table looking at different combinations of volume and intensity and the recovery time and the adaptation time. Again, that's in your notes, and it's pretty straightforward. Okay, so I'm going to turn this back over to Dave to take a look at putting this all together now. Yeah, question?
Just a quick question. Sometimes, even with athletes in a person training environment, you're challenged with the amount of time that you have. If they're in a power phase, would you feel about doing some abdominal exercises or something? Do you think that has a real negative effect?
It depends on the nature of the exercise itself and how far you are pushing that set. So let's say you were doing some vertical jumps or something like that. If you did vertical jumps and then you had them do some kind of crunches or something like that, and let's say you did a set of 30 crunches between your vertical jumps, it's going to have an impact on that vertical jump, because now the core musculature is fatigued, and so your landings all of a sudden, instead of being here and solid, you're collapsing on the core or something like that. You may be able to get away with some grip stuff or something that is totally unrelated to the activity you're doing.
It's more, I was thinking, you could vertical jumps if you had to do a couple of push-ups or something like that.
Yeah, you could actually be doing some rotator cuffs, tubing stuff. If you're doing lower body plyometrics, you could do some grip stuff and things like that. As long as the musculature you're using isn't going to turn around and interfere with the speed power stuff, and as long as the sets you're doing on that second exercise or the exercise in between are not causing fatigue. So it can't be one of those things where, I'm doing some jumps and then I have them do, 40 push-ups. So you can do it, but you have to be careful with how you do it. Yeah?
In terms of total duration, in terms of if we're training power, let's say, 30 minutes to 9 minutes, with 7 minute rest period, which one do you think would be more effective? Or you said it's going to work time, so like, I guess I'm trying to wrap my head around that. Would I sit around for a total 90 minute workout that way, as long as 10% drop off is all?
Yeah, if you're still staying within the 10% drop-off and you're looking at, like if we were talking plyos or something, if you're still staying within those volumes, those guidelines for your volumes, if it takes you 90 minutes to do the workout, yeah, it's going to take you 90 minutes to do the workout. As I said, there are really, really long rest periods in here, so there is a lot of sitting around time sometimes. Any others? Yeah. Will follow very similar rules, because if you're trying to develop power, putting that run in after the power, like it's the whole question of, I guess the question he's sort of getting to is, should you be trying to train power in a fatigue state, because that's how you're going to compete in a fatigue state. You've got these other things going on. Yes and no. If you can increase the power level high enough, so let's say, Actually, let me use a strength example instead, because it might be easier to understand with that. You know, if you took somebody and you knew that in the game they needed to lift 100 pounds, and you got them strong enough that they could lift 800 pounds, doing that 100 pounds in the game would be very easy. So if we use the power analysis now, or the power analogy now, if I can increase somebody's power high enough, then when they do that power activity in the game, you don't have to worry about that fatigue, because they're working at a very low percentage of their max. So that if you have somebody that needs to jump in basketball, you know, if they need to jump 12 inches and they're capable of jumping 36 inches, 12 inches isn't going to really create any fatigue, and it's not going to be affected by anything else that's going on in the game. But if they can only jump 12 inches, and they do that jump once, they might only be able to do it once, maybe twice in the whole game. So we would normally suggest, no, you don't train your power under these fatigue states, that you train power separately, make it high enough so that when you do experience the other fatigue and the running and stuff like that in the game, the power isn't affected by it, and the power doesn't affect the running itself. So we would suggest very similar rules.
All right, guys. Can you hear me again? I guess I was good with that thing. In case some of you are trying to go see Bill Kazmaier and Brad Gillingham, they're going to do some lifting. They're holding off for about 15 minutes or so longer than they were normally scheduled, so that we can kind of get this done. You guys, since probably some of you are interested in that kind of stuff, since you're hanging out for this kind of stuff. So we'll get you a chance to get over there and see what's going on. We have a little bit of a different approach to training than a lot of people, as you've already probably seen. And again, we're very much into trying to develop this explosive power from this ground-based system on up. And we look at trying to put these things together. And so we've come up with a periodized approach that's a little bit different than some of our forefathers of periodization have suggested. And so I want to give that little, share that with you. If you see, this is our continuum here. We've got our max strength and our max speed at either end of the continuum. Notice this triangle is slightly off center. It's located a little bit more towards the max speed end, because power needs that rate of speed development. And the training has to make sure we have that speed element. So now how do we do this? And this is the problem we have. Ultimately, if we were to train, this would be the ideal training setup, where I would train my strength and my speed at the same time. And then after a few weeks of doing that, I would then begin to cycle towards the power by training my strength speed and my speed strength at the same time. Ultimately reaching power at the end of this thing and doing a power cycle of some sort. Yeah, that would be wonderful, but that can't happen. Because when I train very, very fast, I lose the effect of my strength training, and vice versa. So I've got to make choices. The problem is I've got to make choices based on a certain amount of time that I have. What we've also found with our training is that the cycles should last only about 3 to 5, maybe 6 weeks at most. That most of the effects of a true training cycle begin to start to diminish, because all the other factors, some of the factors Ed spoke about, fatigue and so forth, begin to take a toll. Talking with most of the strength coaches out there, strength cycles, speed cycles, power cycles tend to only last for about 4 weeks or so before you start to see the tailing off effects. Now, why is it that some of you guys say, that's not true, I work out, I've been doing it for 12 weeks, 16 weeks and seeing gains? That's probably because you have not been working maximally all along the way. Remember what Ed has said? Talked about doing 100% effort. And until you truly give 100% effort for your workouts, this is very hard to comprehend for most people. Because if you're doing traditional percentage-based training, that percentage-based training typically starts you out at 60 or 70, even 80% of your one repetition maximum. When clearly, we have seen that you need to be training at 85 or 90% if you want to start seeing those adaptations take place. Well, when that happens, the effect after 4 weeks or so starts to get to you. It's pretty easy to do a training session when you're doing sets and reps for a hypertrophy program. Because we know that the reason why hypertrophy programs tend to work is because they're really good at stimulating the testosterone response and so forth. That draws back to the fiber analogy that Ed spoke about in the very beginning. That's not what we want with our athletes, right? We're working maximally. You are going to need to rest. You are going to need to recover because the neurological recovery is not going to be as quick as the rest of the recovery. So we started proposing some ideas, and those who sat with us on Friday saw that we have actually several different periodized plans. But this is just one I've selected to kind of talk about with you today for a few minutes to explain to you what we're doing. And that is, we're starting at our strength end, and we're going to finish with power. And they're just kind of separated by these lines just to give you an idea that they're spaced apart. Each of these phases last about 4 weeks or so, and you move on. Now, the nice thing is if your athlete has a specific level of strength or speed or power, any of these elements, then you can remove them from the cycle, or you can reduce the length of them from the cycle. So right now you're looking at about a 20-week cycle, but that 20-week cycle could be down to 16 or 12 weeks, depending on where your athlete starts and when you pick up your athlete. Take myself, for example, as a power lifter. I think I've got a pretty good strength base. In fact, I probably have way too much of a strength base because I'm slow. I don't have real good movement patterns because all I do is lift in a linear line or do a couple strongman moves and things like that. If I wanted to get myself to where I was more explosive with that strength that I have developed, I need to figure out a way to take it to there. But I don't need to start here. Okay, so this theoretical model then gives you an idea of where you can kind of set yourself in along and what you need to do, versus some of the folks that go out there and talk about periodization and suggest everybody needs a hypertrophy, everybody needs a strength phase, everybody needs to peak. How many soccer players need to do a 1 repetition maximum? Okay, so we're not under this opinion that we need to go through this specifically designed program every time. We need to cater it to our sport. And that gives us something that looks like these things here. So I spend time in my speed strength zone, spend time in my high speed zone, spend time in the strength speed zone, and so forth. Which says when you do it this way, then, if you go back to that analogy, the cycle I've got, you start with strength. Well, that makes sense. But then to get to strength speed, what we do is keep the strength the same and start to build speed at that strength level. That goes back to what Ed suggested about now looking at the velocity. Instead of using the number, the percentage of your 1RM, look at the speed you're trying to match at a certain weight. That tends to build up this level. Then we can drop off all the weight we've got and start working on the speed end. And at first, when you do that, most people are under the impression that if I lift really heavy weight and I just drop it all off, I'm going to be so much faster. It's like the baseball players. My baseball players always swing those bats with that stupid thing on the end of it, thinking that it's going to make them faster when they take it off. No, it's just going to alter your muscle pattern. That takes time to get that coordination from the strength you've just developed. So actually, the first week or two of your high-speed training cycle is going to be spent adapting to the high speed. So you need to give that a little bit of time, and then all of a sudden you'll start to see the improvements really happen. Then we go to the speed strength. So we do high-speed training by increasing the weight. So now we started with a strong person. We've then increased the speed at that, dropped off all the weight, increased all their speed. We're bringing the weight back. Because remember what power is. It's the combination of your strength and your speed. Let's bring it back, introduce it back again for about 4 more weeks, and ultimately you're going to see power. And it makes sense when you look at it that way. Why should I spend time in different training cycles that have no relevance to the sport that I am working with? Just because the periodization model says I need to do that. Okay? It's a little bit different way of thinking when you look at it this way. So how do we do it? Speed plays a greater role, so we want to train explosively at all times. Ed suggested that. We mentioned this fact that we also like to keep ourselves in good shape on the rehab, prehab thing. So every now and then we'll throw in these transition cycles where we just change up some of the movement patterns and so forth, give the neurological system a break from what it's normally doing. Here's how to look at these phases, and then I'll show you how we put it together in our periodized models in one moment. So what this says is these are relative percentages of where you should be. Now, I always look at this one here because you see 50 RM. No, we don't test 50 RM. That's just to give you a relative idea of how light the weight should be when you're looking at high speed. Little weight, no weight. If you're going to add weight, you might get up to 10, 15, 20% for those that are really proficient at high speed weighted movements. In most cases, though, our strength is going to be 80 to 85%. Notice how it says power here is 40 to 60%. That's 40 to 60% of your 1RM because that's found to be where the most explosive activity can happen. A little bit lighter weight, a little bit faster movement, most explosive. So if you take this kind of thing into consideration, it starts to make a little sense. Now remember what Ed talked about with the rest times. So we're seeing reps here of 8, 6, 8 reps. You're talking pretty large rest times in these workouts to make the speed and strength at those weights. Okay? So yeah, they do take a long time. In a time-condensed situation, so I told you when I started here that I worked out, I coached the University of Miami players. We had like 45 minutes in the weight room. And now we're telling you we need an hour and a half to do a workout. So how did we do it? Well, obviously, we focused on just a few single concepts that we could control, and that's why we put together the cycle. I can't do it all at once. So I have to pick what I need, and I do it based on my position-specific needs of the athlete. That's how much time I'll spend on strength, speed, power, based on their positional needs. Okay? So here's how it kind of looks when you put it into these charts. This is a traditional weightlifting model. And remember, this is how periodization kind of began. Brought weightlifting in and decided, if we could come up with a way to start an athlete out and have them peak by the competition for a 1 rep maximum, this would be an ideal way to do it. And it is. It's great for weightlifters. But that's not going to work for you guys out there working with your multi-sport or team-type athletes. And so what these things refer to, and we'll show you how we put it together in a moment, this thing refers to the volume, and notice as the volume actually decreases. Because when I get towards this point here, I need to be able to rest. I need that maximal neurological recruitment time to do a 1 RM. So logically, the volume that I do is going to have to be significantly reduced. The intensity, though, goes up the opposite way, right? Because now I'm going to work at a much higher percentage of my 1 RM max. This is our rep range, the intensity, relative intensity, then low, all the way up to very high intensity, and our volume, again, is going to move around a little bit, but it's typically going to start low and get to a pretty high end and then come back down. Now notice at the end of this thing, I've also got these dates down here and so forth. This is on a 12-week cycle, a 12-month cycle, or what we call the macro cycle. So obviously this would vary from sport to sport. Let's say your sport has 3 major competitions. Let's say your sport has, a 17-game season, and that season happens between this time. Then obviously these things are going to change. And that's what this shows you. As a football strength coach, we've got to set up our programs, and we've also got the problem called coaches that kind of dictate when we test people and give them numbers. So we stick those in there, but we modify this thing for the football season. This is a periodized model, you guys have this on your CD, for a college football team in the United States on their season. This is what we did and how we brought along. In the off season, we kind of messed around with a little bit of hypertrophy. But this was our speed, strength, power, bringing it up to the seasonal demands. And then as the season wore on, we started to decrease everything so that we could perform for the bowl games and so forth. Okay? This is what we'd like to do. We'd like to kind of set this up where we're working with our different clients. Now, I've got this set up here to work for clients. So when you guys see this on your CD, this isn't really an athletic model. This is more of what you might do with your general clients. And it works quite well. And it just kind of shows you these are the kind of workouts we do, and we split things up, and we have our varying levels of intensity as we go throughout. And as I break it down to smaller periods, so we look at it from 12 months out, and then break it down for 16-week periods, and then even further down to a 1-month period, you'll see how we kind of always have these dips. These dips refer to that extra rest that we are imposing, as Ed suggested, catches up with you. So I'm talking about these 4, 5, 6-week cycles begin to slow down a little bit. I can start out with about 6 weeks, cut it back to 5 or 4 weeks before I have to start to impose my rests. And depending on how high it is, we even stick some rests within the week, and these are week-by-week workouts, and a 3-time-a-week workout, even after about week 2 of this heavy, engaged, 100% effort workout, you need to throw some rest in. If you guys get a chance to catch up with Brad Gillingham, he's getting ready to go to South Africa for the World Powerlifting Championships. And he's basically done his workouts now. And it's about, another 8 to 10 days away before he leaves for the thing. And he doesn't want to get himself hurt in between, and he's given a huge amount of rest time so he gets all the neurological recovery necessary so that he can peak when he gets there for the one effort attempt. Okay? That's the kind of thing we're talking about when we set up this cycle. So, just for interest's sake, if you get up to our website and hang on to this website address, we actually have a whole bunch of free information up there, so you're more than welcome to kind of hop up there, see our conferences that we've done before, thumb through the pages, and you'll actually find a lot of this extra information up there. We'd like to thank you for your time and hope you had a good time here, and appreciate you hanging out.
First, we'd like to present you with a memento for the
Thank you.
presentation. And
Thank you very much. Thank you. Wow. That's awesome. Cool. Thanks, guys. They work too, yeah. That's awesome.